Hey guys, welcome to Coronavirus Earth Science. We are on day 5. It should be Thursday if you're doing this right. We just finished big lesson yesterday on pressure. Now we're going to take pressure one step further and talk about how pressure leads to winds. All right, don't forget that your grades this week are the layers of the atmosphere lab and the Google form that you should be doing tomorrow. Do not try to do the Google form before this lesson. You will get stuff wrong. All right, I will be checking this Saturday morning, so get it done Friday. All right, all of that done by tomorrow. All right, so how does atmospheric pressure generate winds? That's where we're heading. That's what we're going to talk about today. But before that, I just wanted to summarize the stuff that we learned yesterday. All right, low pressure versus high pressure. All right, the way that you should remember this, that W in low gives you really important information. That means that the temperatures will be warm, that the moisture content will be wet. And if it is wet and raining, that is going to be your bad, stormy weather. Okay? Next, high pressure. It's going to be the opposite. It's going to be your cooler temperatures, your drier temperatures, and it's going to typically be your nice, clear days. Okay? Now listen, if it's cool, right, like it says right here, that means that it's going to be sinking air, right? Because it's going to be more dense. This is going to be rising air, right? Because it is less dense. All right, and we're going to go adding to this a little bit more today, but that's where we left off yesterday. Okay, so this here is your tool for measuring a certain something. You should remember this as a barometer, right? Air pressure is going to push down, the mercury goes up. This is your air pressure. Over here, what's the relationship between elevation and air pressure? Again, this is your page 14 in your reference table. The higher up you go, the less air pressure you have. There's less air on top of you. Okay, so you guys should remember these. We spent a whole ton of time on mapping in the beginning of the year. These are ISO lines, right? Lines that connect points of equal whatever. So here, every point on this line is going to be 10, 12, right? Now, of all the ones that we went over elevation, which were contour lines. We went over temperature, which are isotherms, and we said that there is pressure, which is isobars. This is definitely not elevation. This is definitely not temperature. We are talking about pressure. All right, typically when you see numbers like this, we are talking about pressure, and they even gave you the H and the L there to help you out. Okay, so important things to know. All right, let's get a couple things out of the way. So we just said isobars are lines that connect points of equal pressure. All right, everything on that same line, it has the same pressure. Fine. Pressure gradient. All right, gradient, you guys remember the formula. This is page 1 of your reference table. All right, it's change in value over distance. Okay, so fine, it's the rate of change. Steep pressure gradient. All right, so if you have a high pressure gradient, how are those lines going to look? All right, you should remember that they are really close lines. All right, so steep means high pressure gradient. Not high pressure gradient. All right, that means that there's a big change going on. If it's a gradual pressure gradient, that means that it will be a lower pressure gradient. That means that the lines will be more spread apart and that there's less change going on. Okay. So, big things with wind. All right, wind depends on pressure gradient. All right, so winds occur when there is a pressure difference. Okay? If the pressures are exactly the same, there's not going to be any wind. There has to be a pressure gradient, a pressure difference. And wind is always going to blow from high pressure to low pressure. Just like temperature, just like heat goes from high temperatures to lower temperatures, wind is going to blow from high pressure to low pressure. All right? Wind direction is always described based on where they come from. All right, so in this particular map example that we have here, this would be called a northwestern wind. All right, because if you have your compass here, the wind is going like this. It is coming from the northwest. So winds get their names based on where they come from. Okay, so here we go. A couple tools. Anemometer is a tool used to measure wind speed. Basically, the stronger the wind, the faster these little cups turn. All right, very self-explanatory, pretty simple. Some people have it outside of their houses. We have one in the classroom if we ever get back there. The next one is a wind vane. Commonly, you guys have seen these before. It's something you see on like barns. Again, some people have them on their houses. It's used to measure wind direction. Wind blows, the little rooster turns and shows you the direction that the wind is blowing. Okay. Wind strength. So we said already that when the lines are close to each other, you have a strong wind, a higher pressure gradient. All right? Higher. All right? Fast winds have a higher gradient, and that's going to be your close lines. All right? Slow winds are going to be over here. They have a lower gradient, and that is going to be the ones that are more spread apart. Okay? Fine. So this is, you guys have a printout of this already done, but I figured I'll walk you through it step by step. Try to stick with me here, okay? So here's location A, the house on the left, and B is on the right. So take a look. You got this house. It is a low pressure area, and you know that because it's warm and it's wet. And if it is warm, it is less dense and it will rise. So you have air going up. And as your elevation increases, as you get higher, is it going to get colder or warmer? You guys should know at the top of mountains, most of the time you have snow, so it's going to get colder. All right, it's going to cool, and then condensation is going to happen. That means you're forming your water droplets, and then you get your rain. And that, again, is why low pressure systems have rain. Okay, now you got rid of all that moisture. Now you have dry, cold air. That dry, cold air is going to be your high pressure system, right? Cool, dry, nice, clear skies. That's going to be your high pressure system. And since it's cool, it's going to be more dense and it will sink. Then it's going to warm up at the bottom. And then look at what direction the wind blows. Wind always blows from high pressure to low pressure. Okay? So here you had your high pressure system on the right at the house B, and then you had your low pressure on house A, and the wind that you experience on the surface. Notice I'm talking about the bottom line, not the top. That is going from high pressure to low pressure. Okay, so a couple other things we got to talk about. Cyclone. You guys have heard of tornadoes, right? And when you hear of tornadoes, you think of a cyclone. Well, last time I checked, that is bad weather. So that is your low pressure systems. All right, so low pressure systems, it doesn't, what the hell? It doesn't have to be a tornado. It could be any bad weather. All right, any bad weather is going to be considered to be your cyclone. All right, I don't know why that happened. great thing to technology stuff. All right, so anticyclones are going to be the opposite. So cyclones are low pressure, high pressure is going to be anticyclones, so the opposite. Take a look at your isobars. Notice that going in towards the center, the numbers are getting lower. All right, so when the numbers get lower as you move towards the center, that makes it a low pressure system. Okay, so fine, take a look at the way the surface pattern winds move. All right, this is a counterclockwise and the winds are going in. All right, they're converging on the center. So you got your warm and wet air, your lowest pressure in the center, winds move towards the center, that's a big one, in, and the winds move counterclockwise. All right, easy way to remember this, loco, low pressure, convergent, okay? And then here, this is the one that I like to use, low pressure, in, counterclockwise. You do have to know and be able to draw these winds going like that, okay? So obviously if that's low pressure, high pressure is going to be the exact opposite. Now look at what's happening as you move towards the center. What the hell is happening? Oh, I'm not doing another retake, guys. It's all happening right now. All right, so as you move in towards the center, on the high pressure, you'll notice that the numbers are getting higher as you move towards the center, okay? They're getting higher as you move in, and notice the winds are doing the opposite. They're going clockwise and they're going out. So you got your cool and dry for high pressure. High is pressure in the center. They are diverging and they are going clockwise, whereas these were converging and they were going counterclockwise. Okay, high pressure divergent and high pressure out clockwise. Okay, so very important page. Make sure you understand and can relate all this stuff. So on this page, this is just summarizing everything that we said. So you have this and you have this. High pressure goes out and clockwise. Low pressure goes in and counterclockwise. And winds always blow from high to low. Okay, so you have to find the one that makes the most sense. That would be this one. Look, high. It's going out and clockwise, right? Out and clockwise. This one's going in and counterclockwise, and the wind is going from high to low. Over here, Earth's surface winds generally blow from high pressure to low pressures. And here, where is the wind speed going to be the greatest? Where you have the greatest pressure gradient on the eastern side. Okay, so your job is to make sure that you get, so this was all your notes. Your job is to make sure that you get this page and this page done. All right, make sure you get both of these pages. This is a good wrap up of everything that we just went over. Okay, as far as our summary that we were talking about before, here on your other one, I just added this in on the content library for day 4. Make sure that you have this entire page. Okay, this is really, really important. All right, so that's basically it. That's your notes for the week. Just make sure that you get your lab and your Google form done by tomorrow. Have a great day, guys. Bye.